So let's look at y equals 1/3 x plus 2. Now, when you're making a t-table of values, you have control over the values that you pick. Now, since I know that I'm picking my x values, but I've got a fraction here, I want to choose wisely. I want to be able to plug in values that are going to make sense and that are easy to work with. Can you always do 0, 1, and 2? Yeah. Is it always going to be the best thing for you? No. Now 0 I think is always a good number to plug in, because that means that's a lot of work that you don't have to do. If I plug in 0 for x, what's 0 times negative 1/3? 0, and 0 plus 2 is just... So you didn't have to worry about the fraction there. But if I were to plug in 1, I'm going to have a fraction, right? What can I plug in here so that hopefully I don't have to worry about fractions? I could do 6. I could do 3 as well. But notice the numbers that you guys said. You said 3 and 6. And those numbers are multiples of this denominator, right? So if I pick multiples of the denominator and I plug them in, then I should be able to simplify away my denominator and be happy. So check this out. If I do negative 1/3 times 3 plus 2, what's going to happen here? Negative 1 plus 2 is just 1. Right? If I plug in the 6, I've got negative 1/3 times 6 plus 2. How do I simplify this guy?
5, 6, 3.
So 3 goes into 6 twice. Make sure that you see this. That's negative 1 times 2 plus 2 is what?
0.
It's 0, right? Now look at the pattern that we have here. What are we doing with the x's? What's the pattern?
X is going up.
I'm increasing it by 3, and what's the y doing? It's decreasing by 1, right? Do you think it would keep doing that? Like if I went to 9, do you think it would have the same pattern?
Yeah.
So let's suppose.
Is that any relevance because we're dealing with the fraction as far as the way it's going up and the way one side's
Are you saying, are these numbers related to this fraction right here? Is that the question?
Yeah, I mean, well, no, I'm sorry. As far as the value of x going up by 3 and the value of y going down by 1, is that relevant to the fact that we're dealing with a fraction, or?
Yes, very strongly connected with that negative 1/3 right there. And that's one of the things we're going to be exploring as we look at the graph of this. Now, I was increasing x by 3 because I had the choice to do that. And by picking multiples of 3, like I could have picked negative 3 or negative 6. But by picking multiples of 3, it would reduce with that denominator, and I'd be left with a whole number. And I feel happier with whole numbers, right? Okay. But if I look at this pattern, if I'm trying to say, well, you know what? If it keeps in that same pattern, if I increase this by 3, what should the next number be in that pattern? Negative 1, right? Let's see if that's true. If I take these points and I plot them, I've got 0, 2, 3, 1, and 6, 0. What's the pattern that's going on here as I go across here? Down 1 over 3, down 1 over 3, and so on, right? If I go down 1 and over 3 again, guess what point I have? I do get that 9, negative 1 point that we thought we should have, and we do have. Now, of course, you can go the other way on this guy. Go up and backwards 3. The more points you get, the more accurate your graph is going to be. Right? Question?
No.
Okay. Say again? Okay. So these guys are a little too far apart for me, so I want to make sure that I am accurate. So remember, the line represents all solutions to that particular equation. So I'm saying any point on this line would work for the original equation. Do you all agree? Now, since this equation was already solved for y, you should be able to easily plug that into your graphing calculator and get the same thing. Now let's check and see what one plot gave us. And it looks pretty spot on to me. How about you guys?
Mm-hmm.
What do you think? All right. Now, there's some really neat stuff that I want to talk to you guys about when I look at the graph here. Okay. There is something called slope, and I know a lot of you will remember this. When we talk about slope, we talk about rise over run. That's the three-word phrase that pays. Okay, rise over run. Now, a lot of times with rise over run, we talk about this with delta y over delta x, the change in y over the change in x. Okay, so we're literally going to say that the change in y over the change in x. That's what slope means, the change in y over the change in x. When you're going to take something like calculus, you get to look at slope in a much more precise way, and it's actually pretty stinking awesome. Sometimes we'll use the letter m to represent slope, and since we're talking about the change in y and the change in x, we can write it like this. So that y2 minus y1 over x2 minus x1, that is equal to your slope. When we talk about change in something, we want to find the change from one thing to the next, you do subtraction. That's why I have the subtraction here. And these little subscripts here are used to denote, point 1 from point 2. What I want to look at, though, is look at this graph that I have. As I go from this point to this point, okay? So I'm talking about this is my slope. I'm saying this is my rise over my run. How much did I rise as I went from this point to this point? I actually went down one, so that's a rise of -1, right? What was your run as I went over here? What was the change in x?
3.
You all agree with -1/3?
Mm-hmm.
Okay. That -1/3 sounds familiar, like I've seen it somewhere, right? But just so you understand something about slope, it doesn't matter what 2 points you pick on the line. The slope is always the same. If I go from this point right here to this point right here, so as I go up and over, okay, sorry, we're recording at an airport. It usually doesn't happen. Usually the planes are grounded.
Can I stop for a second, please? Okay, y squared minus y,
It's not square, those are subscripts. And there's a difference. If it's an exponent, that's something completely different. But it's used to denote the difference between having x1, y1 and x2, y2, just denoting the two coordinates. The first x and the second x, the first y and the second y. Now if I go from this point to this point, what's your rise? I mean, you can just count this and what do you get? You went up 4, didn't you? But when you run, you go to the left, so what does that mean? If you count that, that's -12. What's 4 from -12?
1/3.
What's your signs?
Negative 1/3.
-1/3. Have we seen the -1/3 anywhere?
Mm-hmm.
Oh, and goodness. You think there's a connection between those two? Maybe? Yeah. Now, if you're using this formula for slope, okay, the order pair here is 6, 0. The order pair here is -6, +4. So, according to my slope formula, My slope is the change in y's over the change in x. So if I just happen to label these guys the following. This x1, y1, I call this one x2, y2. In my formula, what's y2? 0 minus what's y1? Over what's x2? Minus what's x1? So the minus is from the formula, but x1 coordinate is actually -6. So this gives me what? -4 in the numerator. What's in the denominator? Negative times negative makes that guy positive, so 6 plus 6 is 12. And again, this will reduce to what?
-1/3.
-1/3. Doesn't matter what 2 points you pick, it doesn't matter which direction you go, it's still going to reduce to a slope of -1/3.